I'm going to be doing a teardown of this Mustool MDS8207. It's a Oscilloscope Multimeter combo. So first thing you want to go ahead and do is remove your AA batteries and put them aside. Then go ahead and remove the 4 screws that hold the casing together. Unfortunately, they do use these self-tapping type of screws. So what that means is these thread into plastic on the casing. And just by unscrewing and screwing them in, you will wear out the threadings over time, or if you over time, you can just strip the threadings right out. So you do have to be very careful with that. So next thing you want to go and do is just simply remove the casing. And here you can see the foil they use actually has shielding, so at least it does have some sort of shielding on it. And down here is the post that actually helps secure the post in place. Well, there's not much to look in the back. Now we can go ahead and look at the meter part pretty much. In here I'll give you a close-up of everything. Here's your AA holder and there's your post. So first we'll go over the pretty much front end of it. And they're using these split posts, which I don't like because it's just folded metal over this, and over time by plugging that in, that's going to end up metal fatiguing over time. So I really don't like that. The other thing I don't like right off the back that I see is the fuses. It's using SMD fuses. Not good, because if you're prone to actually blowing fuses, you will have to order these from your part supplier, and then you'll have to wait and then unsolder and solder new ones in there. And same thing with the other fuse right here in the milliamp range. And then they're using a small PTC and a MILF resistor right there as your input protection. On this side here, which this here goes to the oscilloscope portion, they're using an MOV right here, and then there's another MOV right underneath this board. We'll have to remove that to see what else is under there. And then here you also see some more MILF resistors right on the side of the battery holder right there. As far as capacitors go, they went ahead and actually wiped off some of the markings on these 2 capacitors, and I have no clue why. They did a really poor job in it. But you have 2 caps right there, and then you have another capacitor right here, which is a 470 microfarad 16 volt, and unfortunately it's a no-name brander. Now as far as what they're using is, they're using a LC04A hex inverter, so you can see that right here. And then they scrubbed off the numbers on that regulator right there. Then here there's an 8 megahertz crystal. The rest are just SMD components on there. So what I'm gonna have to go ahead and do is unsolder these right here and then unsolder that, and then we'll be able to lift this board array to see what's under there. So finish removing the FPGA/microcontroller board, and you do have to unsolder these 2 posts right here and these 2 posts right here. You have to unsolder to be able to remove it, and the rest is just connected right in there. You can just pry this off very carefully off. And here we'll go ahead and take a closer look at the analog section pretty much. And here's your ADC switch circuit. And I'm not sure you can get a close-up view, but there you go. You do have 2 relays right here. Here's the other MOV/MILF resistor right there. One nice thing I noticed is they did go ahead and solder down the actual crystal to the board, so vibration won't fatigue those leads over time, so that's a good thing. Then we'll go and put this aside real quick, and we'll look at the FPGA microprocessor board. Let me see, let's turn it around. Hopefully you can see that. And here they're actually using an LCM X02640HC FPGA chip. This here, of course, is your STM32 microprocessor right here. This here is likely your EEPROM that actually stores the calibration settings. And here's likely the ADC that they actually scrubbed the numbers off so you wouldn't be able to tell what it is, but there you go. And give you a close-up of the board right here. And we'll go to the other side right here too. Yeah, for your power filtering, this is your inductors and your capacitors showing you earlier. Your hex inverter is right here, and your linear regulator. And then here's the crystal on this board right here. And then there you go, there's the markings of this board right here, which likely goes to another meter as well. Okay, so now we'll go ahead and take the main board out. Take a look to see what's on the other side pretty much, and there's not much on the other side. You have your current shunt right here, and thankfully solder does go all the way through the post. So yes, they did solder these in properly at least, so it's soldered on both sides. Sometimes I've seen where on cheaper meters where they'll go ahead and put solder on this side, but it doesn't go all the way through this side to save on solder. And there you go. Here's for your transistor tester right there. Your backlight is soldered onto there, so I'm not going to remove because I don't want to destroy this meter, but your backlight's here, and then there's your panel. And that's all we need to look at. Oh wait, the wipers on the meter too as well, and they are using dual wipers. And you can see in there they do have slots so it stays in place. And then your regular push pads right there, and the inserts to hold and center the post onto there. And as far as anything else interesting, I mean, I could remove this battery holder, but I'm not gonna do that. It does look like the contacts are gold plated as well, so that's a good thing. So I'm gonna go and get this meter back together and hope that she still works after I'm done. So one thing you want to go ahead and do before reassembling your meter, if you did take yours apart, is you might as well go ahead and use electronic grade silicone to secure the components down, so that way if you drop the meter and stuff like that, or you know, over time these are not just going to go ahead and vibrate and metal fatigue off the board. I also did this one under here too as well. I mean, you can also use hot glue as well. Just make sure you don't use regular silicone, the type that smells like vinegar as it cures, because it will go ahead and eat through the board pretty much. So don't use that. Use electronic grade silicone if you're gonna go ahead and do that. So I went ahead and fully reassembled the meter, and let's go ahead and see if she survived the teardown. So we'll go ahead and power it on. That's a good sign. Okay. Yep. Alright. And then the oscilloscope part. There you go. So she did survive the teardown.